Rogue planets are celestial bodies that drift alone through the vast and dark expanses of space, untethered to any star. Without a sun to provide warmth, their surfaces remain frozen, and they experience neither seasons nor the passage of days and nights. Yet, paradoxically, these wandering worlds might still harbor life, spreading it to the far reaches of the galaxy. But how is this possible, and how do planets become rogues in the first place? The origins of rogue planets. There are several types of rogue planets, each with a different origin. Some, known as sub-brown dwarfs, are gas giants that form from collapsing clouds of gas, much like stars. However, they lack the mass to ignite nuclear fusion and remain failed stars, drifting aimlessly through space. A more fascinating type of rogue planet is the terrestrial variety, rocky worlds similar to Earth that are ejected from their planetary systems. In young star systems, planetary formation is chaotic. Protoplanets compete for mass, colliding and disrupting each other's orbits. If a massive planet migrates closer to its star, its gravitational influence can fling smaller planets into the void. Even mature planetary systems are not immune to disruption. Passing stars or black holes can destabilize orbits and send planets careening into interstellar space. Scientists estimate that up to half of all planets ever formed might end up as rogues, with billions potentially roaming the Milky Way. The harsh reality of a rogue existence. Most rogue planets face a bleak fate. Without the warmth of a star, their surfaces plummet to near absolute zero -270 degrees Celsius. If they once had oceans, they freeze solid, becoming as hard as rock. Their atmospheres, lacking the energy to remain gaseous, condense and freeze onto the surface. These planets become barren, icy wastelands. However, under certain conditions, life might still persist in the darkness. The possibility of life on rogue planets. For life as we know it, liquid water is essential. Although rogue planets lose nearly all of their energy sources without a star, they still have a small but crucial reservoir of heat, geothermal energy. Earth's core, for example, is a searing hot metal ball, roughly as hot as the Sun's surface. Surrounding it is an outer layer of liquid metal that gradually solidifies, releasing heat in the process. This geothermal activity could sustain a rogue planet for billions of years, providing enough warmth for subglacial oceans to exist beneath a thick ice shell. Another factor that could help maintain liquid water is a dense hydrogen atmosphere. If a rogue planet retained a thick enough atmosphere, it could trap heat effectively, preventing surface oceans from freezing entirely. Additionally, if a rogue planet had a moon, tidal forces could generate internal friction, providing another source of heat. This stretching and squeezing effect, similar to how Jupiter's moon Io remains volcanically active, could contribute to maintaining subsurface liquid water. Alien ecosystems in the deep. If a rogue planet harbors an ocean beneath its frozen surface, life could exist in a similar way to Earth's deep-sea hydrothermal vent ecosystems. On our planet, these vents, known as black smokers, spew mineral-rich, heated water from the ocean floor. Microorganisms thrive on these minerals, forming the base of a food chain that supports an array of creatures, from snails and crustaceans to tube worms and even fish. If a rogue planet has hydrothermal vents, they could serve as a foundation for alien life, possibly even complex organisms. A unique advantage of such an ecosystem is its stability. Unlike surface life, which is exposed to natural disasters, climate shifts, and cosmic events, life in a subglacial ocean remains insulated from external threats. As long as the planet's core remains warm, life could persist for billions of years. The limits of rogue planet civilizations. While microbial and even multicellular life might thrive on a rogue planet, the development of intelligent life faces significant obstacles. Without sunlight, there would be no photosynthesis, no plants, and no easily accessible energy sources like wood, oil, or coal. Even if a civilization emerged, it would be confined by an impenetrable ice barrier, unaware of the universe beyond. Without the ability to harness fire and smelt metals, technological advancement could be severely limited. Millions of generations could live and die within these dark oceans, oblivious to the stars above. When the planet's core finally cools and its oceans freeze completely, all traces of life and civilization would be entombed in ice forever. A universe full of hidden life. The thought is both haunting and exhilarating. The universe could be teeming with life trapped on frozen rogue planets, unable to escape or communicate. These worlds could pass silently through our solar system without us even knowing. Perhaps, one day in the distant future, humans will land on one of these planets, drill through its icy crust, and discover an alien ocean filled with strange, unearthly creatures. When that moment comes, it will be a profound encounter, a message from the dark depths of the universe that life, no matter the odds, finds a way to endure. Road planets are planets that travel through the universe alone. They inhabit the dark and vast space between the stars. Drifting alone through eternal darkness, no light warms their surfaces. And they're exposed to the freezing cold of outer space. They know no seasons, no days, and no nights which could give away the passing of time. And yet, road planets might carry alien life to all corners of the galaxy. How would that work, and how does a planet become a rogue anyway? There are several very different things that get called rogue planets. For example, sub-brown dwarfs, gas giants that form from collapsing gas clouds, and are the boring little brothers of brown dwarfs. They're a sort of failed star, and we'll now start talking about them. A far more interesting sort of rogue are terrestrial planets similar to Earth, that got kicked out of their planetary system. Young star systems are dangerous places where protoplanets are battling for the available mass, guzzling up as much material as possible. In this fight for dominance, they collide with each other, or get dangerously close to each other's orbits. If a very massive planet moves its orbit closer to the star, it can kick smaller planets out of the system. But just because a planet has survived the growing pains of formation doesn't mean it's safe. Planetary systems can be disrupted by flybys from stars or black holes at any point. Up to half of all planets born could end up as rogues. Scientists don't agree on the numbers, but it's likely that at the very least, there are billions of rogue planets in the Milky Way alone. Most rogues will share the same depressing fate. As their star becomes smaller day by day, the planet's surface quickly cools down to -270 degrees Celsius. If they have oceans, they'll freeze and become as hard as bedrock. Their atmospheres will sink down to the surface and eventually freeze too. But weirdly enough, some of these frozen, dark deserts could harbor life. To understand how, let's imagine a planet similar to Earth, in the same order of magnitude in terms of mass and composition. If we put it into deep space, how could it still support life? As far as we understand the nature of life, there is one indispensable ingredient it needs: liquid water. Water is important because it mixes things, both matter and energy, which lets interesting chemistry happen, like life. So our planet needs enough energy to keep at least a part of our oceans warm enough to sustain liquid water. Annoyingly, about 99.97% of Earth's energy budget comes from the sun. So our imaginary rogue Earth needs to work with the 0.03% of energy it has left, which almost exclusively comes from its hot center. Earth's inner core is a giant metal ball about as hot as the surface of the sundae that's surrounded by the outer core made up of liquid metals that are very, very slowly solidifying, releasing a lot of heat in the process. As long as this process is ongoing, our planet will be geologically active, with solid and liquid material moving around and transporting energy to the surface, where it can be harnessed as geothermal energy. While the hot core of every planet will cool off eventually, this process takes billions of years, enough time for life to come into existence and thrive. There's even one scenario that could allow an Earth-like planet to have oceans that are not frozen over. If the planet had an extremely dense and high-pressure hydrogen atmosphere, the gas would not freeze and could trap enough of the heat trying to escape the planet to enable oceans that extend all the way to the surface. And there's another possible way to stay warm: moons. If a rogue planet brings a moon or more along with them, a large enough moon could inject additional energy into the system via tidal forces. These forces stretch and squeeze the planet a little bit every day, like kneading dough, keeping it warm. But the most likely scenario for a rogue-bearing life is one with subglacial oceans, under a kilometer-thick layer of mostly water ice. These are not completely absurd, since we already have a few of them in the solar system. So how could life sustain itself at the bottom of a completely dark, cold ocean on Earth, deep down in our oceans in complete darkness? In volcanically active areas, there are hydrothermal vents called black smokers. They spew out a cloud of black material and hot water, providing a constant flow of minerals from Earth's mantle. Bacteria feed on the minerals and produce organic materials, which attracts crustaceans, bivalves, snails, fish, octopus, and tube worms up to 2 meters long. Not only are hydrothermal vents home to an incredibly diverse group of living beings, but also a contender for the place where life could have begun on Earth billions of years ago. In the dark ocean of a rogue planet, similar vents or volcanic activity could be the starting point and basis for complex ecosystems we can only imagine right now. One upside an ecosystem in a rogue planet ocean has is that the environment is extremely stable. The thick ice sheet protects it from all sorts of extinction events. And as long as the energy from the core keeps on coming, things stay pretty much the same. The most likely forms of life are bacteria and other microorganisms, but given enough time, more complex alien animals could feed on the smaller beings and thrive. It's not impossible that intelligent life could emerge in such an environment. If it did, it would find itself in a pretty weird world, constricted by an impossible wall of rock-hard ice at the top and bedrock at the bottom. Without any plants to store star energy, there would be no wood, oil, or coal. Even if there were, it's not like you'd discover fire at the bottom of an ocean. Without this energy, metals may never be forged into useful things. Our intelligent alien friends might never break through the ice. They might never realize that there is such a thing as outside, and assume that their small world is all there is. Millions of generations might live and die in these dark oceans, ignorant of the unbelievably big universe above the ice, until the core of their planet calls off and all life vanishes. Please like, share and subscribe my channel. Thanks.